Most people believe that building a chip factory is something only Asian giants with decades of accumulated experience can do. What almost nobody knows, in April 2026, excavators started digging on the northern side of the Giga Texas complex, and what's being built there could double the entire computing capacity of the United States. A $25 billion project, 2-nanometer technology, 4 companies that are rarely mentioned in the same sentence: Tesla, SpaceX, xAI, and Intel. And the question that nobody in the semiconductor industry can ignore: who's really in charge of all this? To understand why TERAFAB exists, you have to answer a question that seems simple. What does Tesla actually need to survive over the next 10 years? Not batteries, not motors, not factories. Chips. Every Tesla on the roads today depends on chips to run the FSD autopilot system. Every Optimus robot needs chips to perceive its environment and make decisions in fractions of a second. Every Starlink satellite in orbit needs special chips capable of withstanding space radiation, something you won't find from the usual suppliers. And it was precisely a concrete calculation that forced Musk to break his silence. According to his own estimates, all the chip factories on the planet combined can only meet around 2% of the demand that Tesla and SpaceX will soon have. Not 50%, not 20%, 2%. Musk tried to solve this problem through large-scale purchases. The first response was a $16.5 billion contract signed with Samsung in 2022, July 2025. An impressive figure by any standard. However, even that volume doesn't solve the structural problem. When the most critical component of your business depends entirely on another company, you don't control your own future. That's why, on March 21, 2026, Musk took the stage at the historic Sion power plant in Austin and said something so direct that the entire global semiconductor industry was forced to stop and listen. Either we build TERAFAB or we run out of chips, and we need chips, so we're going to build. There is no plan B. TERAFAB is a joint chip manufacturing project between Tesla, SpaceX, xAI, and Intel, with an initial budget of $25 billion. The stated goal is to produce 1 terawatt of AI computing capacity per year. For comparison, today the United States as a whole produces just 0.5 terawatts. Musk wants TERAFAB on its own to double that number. What sets TERAFAB apart from other chip factories is the ambition to integrate the entire production chain at a single location. Chip design, manufacturing, lithography, memory production, packaging and testing, all in Austin, Texas. It's the first time in the history of the semiconductor industry that a single project aims to control the entire chain from start to finish in one place. But announcing it is easy, executing it is a whole different story. In April 2026, excavators started working on the northern side of Giga Texas. This is the first phase, the prototype phase, covering more than 480,000 square meters on the northern part of the plant. The goal of this phase isn't to produce millions of wafers. The goal is to learn. Production starts at 3,000 wafers per month, a small number compared to what TSMC processes, but it's the foundation. The first chip to be manufactured is the AI-5, Tesla's fifth-generation chip, designed for both the autopilot and the Optimus robot. Small-scale production is planned for late 2026 and mass production for 2027. Why start at such a small scale? Because Tesla has never manufactured chips before. 2-nanometer chip factories aren't learned from books, and you can't just build one by hiring a few engineers. They require knowledge accumulated over decades, atomic-level quality control, and thousands of failed experiments before a single wafer reaches the required standard. And this is where Intel enters the story. On April 7, 2026, Intel published an official statement. Intel is proud to participate in the TERAFAB project alongside SpaceX, xAI, and Tesla. Our capabilities in high-performance chip design, manufacturing, and packaging will help TERAFAB achieve its goal of 1 terawatt per year. The tech community immediately erupted in debate. Some argued that Intel's involvement made TERAFAB more realistic and credible. Others insisted that Tesla can't build a factory on its own, that Intel is the one doing the real work, and that TERAFAB is just a fancy name slapped on top of a manufacturing contract. The truth is that both sides have a point, and that's the most interesting part of this whole story. Intel brings the 18A process, the most advanced on American soil at that time. Intel also brings EMIB packaging technology, which allows different types of chips to be combined into a single module with superior characteristics. And most importantly, Intel brings a deep team of experienced manufacturing engineers, specialists that Tesla could not have trained on its own in several years. What do Tesla and SpaceX bring? A real need, capital, and a name powerful enough to change the rules of the game across the entire industry. This isn't a failure on Tesla's part for needing Intel. It's Tesla being smart enough to choose the right partner, rather than stumbling through every stage of the process for 10 years. Look at the existing precedent. At one point, Tesla partnered with Panasonic to manufacture lithium-ion batteries at the Gigafactory in Nevada. Nobody said Tesla had failed for not manufacturing its own batteries from the start. Over time, Tesla learned, accumulated knowledge, and developed the 4680 battery completely independently. TERAFAB follows the exact same path, just at a significantly larger scale. On April 22, 2026, Musk confirmed that TERAFAB will use the Intel 14A process to manufacture chips. Not the 18A from the initial phase, but the 14A, Intel's next, more advanced node, with a planned launch in 2027. This means TERAFAB is betting on technology that doesn't yet exist on the market. A big bet. But if it works, Tesla will become the first customer in the world whose chips are manufactured using Intel's most advanced process. For Intel, this moment is one of the most existential, in the most literal sense of the word. CEO Lip Bhutan publicly stated that Intel would consider exiting the chip manufacturing business if it failed to attract major customers for the 14A process. Musk became that customer. Intel's stock rose immediately after the announcement. A single statement from Musk was enough to pull Intel back from the edge of the cliff. That's the true scale of TERAFAB's influence on the global semiconductor industry. As for the long-term future, the phase at Giga Texas is just the starting point. Musk made it clear that TERAFAB at full capacity will require thousands of acres at a new location that hasn't been announced yet. The estimated scale is nearly 9 million square meters, equivalent to almost 2,000 football fields. Musk compared the project to Samsung's plant in Texas and said TERAFAB will be roughly 12 times larger. But if you're excited about TERAFAB, it's time to look directly at the real challenges it faces. Because this is an analysis, not a promotional press release. The first challenge is the gap between $25 billion and $5 trillion. Bernstein Research, one of Wall Street's most respected analysis firms, estimates that the real cost of reaching the goal of 1 terawatt of capacity per year falls somewhere between $5 and $13 trillion. That's a gap 200 times larger than the current budget. However, the more balanced perspective is this. The $25 billion is the budget for the prototype phase, not the entire project. TSMC built its current position over 30 years and invested hundreds of billions of dollars in continuous investment. The real question isn't whether $25 billion is enough. The real question is whether Musk will have the patience and the resources to see it through to the end. The second challenge is rarely mentioned, but it represents a limitation that no amount of money can overcome: EUV machines. Manufacturing 2-nanometer chips requires machines that etch circuits using extreme ultraviolet light. Only one company in the world makes these machines, ASML from the Netherlands, and its order book is already full through 2027. It doesn't matter how much money you have, how many engineers you've hired, or how much land you own. You're still going to have to wait. It's a physical limitation of the global supply chain that Musk can't solve with speed or ingenuity. The third challenge comes from a completely different direction: water. Giga Texas already consumes more than 2 billion liters of water per year, a 60% increase in just 2 years, making it Austin Water's third largest customer. A standard chip factory would require a significant additional volume every year, and Austin is located in a region vulnerable to severe droughts. Local environmental groups have sent official letters to the Travis County Court demanding mandatory mechanisms in case Tesla fails to meet its environmental commitments. This problem has no visible solution yet and could become the most unexpected obstacle for the entire project. Before TERAFAB, Tesla bought chips from Samsung and TSMC, paid market prices, depended on third-party delivery schedules, and had no ability to participate in chip design at the manufacturing level. With TERAFAB, for the first time, Tesla will be able to optimize its own chips all the way down to the silicon level, not just at the software level. Everything will be designed for Tesla's specific use cases, not for hundreds of different customers. This difference is similar to Apple's shift from Intel chips to M1 chips in 2020. The result was MacBooks with significantly higher performance and much lower power consumption, and Apple never looked back. Musk is betting that TERAFAB will do for Tesla and SpaceX what the M1 chip did for Apple, only at the scale of an entire industry. TERAFAB isn't a story about a chip factory. It's not a story about Musk wanting to beat TSMC. It's a story about companies seeking to control their own future in a world where semiconductors have become a more important resource than oil. $25 billion may not be enough. Intel 14A could face delays. Austin could face water shortages. But the first stones are already in place. And the history of technology shows that the projects that generate the most doubt are often precisely the ones that end up changing everything. So what do you think? Is TERAFAB the vision of the century or the biggest bet in the history of the chip industry? Leave a comment below. I read all of them and respond honestly. This channel exists for one reason only: to present the world's most complex tech news in an accessible, understandable, and honest way. If this video helped you understand even one thing better, give it a like. That tells me I'm heading in the right direction. If you think I missed an important point, say so in the comments, because your perspective is what makes this analysis more and more complete over time. Share it with friends who are passionate about technology. It's the best way to help this community grow. Subscribe to the channel so you don't miss the next analysis. See you in the next video.